Example 14. Make sure you have your calculator nearby because we'll be using it in this problem. Jeffrey's an 8-year-old boy. He established a mean time of 16.43 seconds for swimming the 25-yard freestyle. The standard deviation is 0.8 seconds. His dad, Frank, thought that Jeffrey could swim faster using goggles, so he bought him goggles, timed Jeffrey for 15 25-yard freestyle swims. For those 15 swims, Jeffrey's mean time was 16 seconds. So Frank, his dad, thought that the goggles helped Jeffrey to swim faster than the 16.43 seconds. It says conduct a hypothesis set using a preset alpha equal to 0.05. Assume the swim times are normal. So the original claim is that Frank thought that the goggles helped Jeffrey swim faster than 16.43 seconds. So that would be faster or less than, in this case, 16.43. So then the competing claim is that it was equal to 6.43. So we know in this situation that the null is this one, and the alternative is this top one. So we can look at the alternative hypothesis, and we can see that this is a left-tailed test. So when we do sketch this out, we'll look something like this. Next, let's determine the distribution needed. So we've got random variable that equals the mean time to swim the 25-yard freestyle. The distribution we already know is normal. So we've got a normal distribution with some mean and then some standard deviation. And if you recall, we find the standard deviation way, and we have all of this information. So we can go ahead actually and fill this out. The mean is 16.43, and then we are going to do 0.8 divided by the square root of 15. Next, we want to calculate our p-value. So our p-value, this is where we're going to get out our calculators, and we're trying to find the p-value when the mean is less than 16. So let's grab our calculators. So to do this, we want to hit the Stat button, go over to Tests. We want the z-test. We want to arrow over, make sure you highlight Stats and hit Enter. Then our mu is 16.43. Then our 0.8, you can just type over it. You don't have to clear it out. The sample mean is 16. The sample size is 15. We want to arrow over to less than, hit Enter. And we're going to arrow down to calculate, and we press Enter. So here, you can see that, and give it so you guys can see it. Okay, so here we go. The p-value is 0.0187. So the p-value, remember, is the level of significance, and right now it's very small. If we go back to our graph here, p-value is here, and this is at 16 because that is our sample mean, which they gave to us. Now we need to interpret the p-value. So this is actually, let's change this to a percentage, 1.87%. So if the null hypothesis is true, I'm just going to put T for true, then there's a 1.87% probability that Jeffrey's mean time to swim the 27-yard freestyle is 16 seconds or less. So if the null is true, then there is a 1.87% probability that Jeffrey's mean time is 16 seconds or less. Because the 1.87% chance is so small, the mean time of 16 seconds or less is unlikely to have happened randomly, and it's a rare event. So let's compare the alpha, which they gave us as 0.05, to the p-value, which is 0.0187. And the alpha in this case is greater than the p-value. And when the alpha is greater than the p-value, we reject the null hypothesis. So this means that we reject that the mean is equal to 16.43. So we think that Jeffrey can swim faster with the new goggles. So then our conclusion at a 5% significance level, because that's what we're using our alpha, the 5% significance level, we can say that Jeffrey swims faster using the goggles.